Everyone, myself Sumukha. I'm a student from SVC, currently studying in first year of engineering. Today's subject is mathematics. Topic is regular falsi and Newton-Raphson method. Overview of root finding problems. In numerical analysis, the finding root problem involves determining the solutions of equations where the function f of x crosses the x-axis. These roots represent the value of x for which the function evaluates to 0, and they are crucial in various fields of science, engineering, finance, and beyond. Importance of root finding. Engineering application. Control systems. Finding roots helps in stability analysis and controller design. Structural analysis. Locating roots aids in determining the natural frequencies of structures. Electrical circuits. Identifying roots assists in analyzing circuit behavior and designing filters. Physics, quantum mechanics. Roots correspond to energy levels in quantum systems. Mechanics. Finding roots is essential for solving equations for motion and determining equilibrium states. Regular falsi method. The regular falsi method, also known as falsi position method, is a root finding algorithm that iteratively refines the root of a function by narrowing down the intervals where the root lies. Key steps. Initial guesses x0 and x1. Start with two initial guesses x0 and x1, where f of x1 and f of x0 have opposite signs, indicating that the root lies between them. Linear interpolation to find x2. Use linear interpolation to calculate x2, the point where the line joining x0 and f of x0 and x1 and f of x1 intersects the x-axis. Update interval based on function size. Determine whether the root lies between x0 and x2 or between x2 and x1 based on the signs of f of x0 and f of x2. Update the intervals of the new bracketing intervals containing the root. Conditions for convergence. The regular falsi method converges if the function is continuous and changes sign over the intervals where the root lies. The method may fail to converge or converge slowly if the interval chosen initially is too far or if the function has too many roots. Mathematical formulation of regular falsi method. The regular falsi method involves iterative calculations to approximate the root of a function f of x. Given initial guesses x0 and x1, the next approximation x2 is calculated using linear interpolation. X1 is equals to x2 minus f of x1 into x1 minus x0 divided by f of x1 minus f of x0. If f of x2 has the same sign as f of x0, then x2 becomes the new guess x1 and vice versa. The process continues iteratively until a satisfactory approximation of the root is obtained. Understanding the Newton-Raphson method. The Newton-Raphson method is an iterative algorithm for finding the roots of a real valued function. It uses the idea of linear approximation and tangent lines to iteratively refine the guesses for the roots. F of x n plus 1 is equals to xn minus f of xn divided by f dash of xn. Convergence for the Newton-Raphson method converges if the function is continuous and differentiable in the neighborhood of the root. The initial guesses is sufficiently close to the root. The derivative f dash x1 x does not become 0 near the root. Understanding the differences. Comparison factors. Convergence speed. A regular falsi method, convergence speed can be slower, especially if the intervals is large or if the function has multiple roots. Newton-Raphson method typically converges faster, especially when the initial guesses is close to the root and the function is well behaved. Computational complexity. Regular falsi method. Generally simpler computationality as it involves linear interpolation and interval updates. Newton-Raphson method requires a computation of the derivative of the function, which can be complex or computationally expensive. Requirements. Regular falsi method requires the function to be continuous and change over the intervals where the root lies. Newton-Raphson method requires the function to be continuous and differentiable in the neighborhood of the root. Limitations. Regular falsi method may fail to converge or converge slowly if the initial interval is poorly chosen or if the function has multiple roots. Newton-Raphson method may fail to converge or converge to incorrect roots if the initial guesses is far from the actual root or if the function behaves poorly near the root. This is all for the video. Thank you for watching.